Let's have a look at functions and graphs and absolute value graphs here. We're just having a look at a quick couple of key examples to refresh our memory. Okay, if we wanted to sketch x plus 4 in the absolute values, y equals x plus 4, absolute values signs outside it, I like to think about what would it look like if it didn't have the absolute value signs. And we've got a gradient of 1, and it goes through positive 4 for our y-intercept. So we would have a line that would generally go down like this and keep going. So what you'll see when I flick over to the next slide is that we take the positive section of that, and when the whole expression turns negative down here, the effect of the absolute value sign is to turn that into a positive. So what happens is it sort of bounces off, and instead of going down further like a normal line would without the absolute value sign. So we end up with this situation. It's y, this section here is y equals x plus 4, the positive section of it, but with the absolute value sign, this bit here that would continue ends up being turned into a positive instead, so it bounces off the x-axis. And that's typical of these absolute value graphs. There's a slight variation here. We've got y equals absolute value of x, but we've got a plus 4. Now, we saw in a recent video that adding a number here moves things up 1. So if you think about it, y equals x plus 4 would look a certain way, but we'll see how that is affected there. So what happens is that the y equals x would look like this, going down here. Y equals x absolute valued, whenever the x value is less than the x-axis, it would bounce off to there, but the effect of having a plus 4 each time moves all those values from my blue drawing up higher. So that's where the red value ends up. So that's an interesting variation, but have a look at a few more absolute value graphs if you're not sure of them, but that's the general idea there. Thanks for listening. Just some quick reminders there. All the best. See you next time.